Good afternoon, everyone. Of SAE Detroit Section and the SAE Washington DC Section, we would like to thank you for joining us today. Before we begin, I'd like to address a few quick housekeeping items. A recording of our discussion will be shared via our YouTube site at a later date. Aside from the panelists, all attendees have been muted to avoid work distractions. We truly want you to participate and have turned on the chat functionality, so please feel free to share your questions with us along the way. And now that we have this out of the way, I would like to turn things over to Becky Mueller from the SAE Washington DC Section.
Thank you very much, Roxanne. I am the Communications Chair for the Washington DC Section. I am also going to be your host for today's behind the scenes tour. After the tour today, there will be 2 crash test experts available for a question and answer session. And so hopefully we can answer all of your other questions that you might have after seeing our behind the scenes tour and about our upcoming programs that we have for new crash testing. So without further ado, I am going to switch it over to our behind the scenes tour.
Hi, I'm Becky Miller, one of the senior research engineers here located at the VRC. Welcome to the Insurance Institute for Highway Safety's Vehicle Research Center. We're located in Ruckersville, Virginia, in the foothills of the Blue Ridge Mountains. This is the location where we conduct all of our car crash testing. In March of 2020, the Institute closed for 3 months due to the COVID pandemic. When we reopened, we made sure that there were safety precautions put in place for the limited number of staff that were essential to conducting crash tests and coming into work every day. This includes wearing masks, as well as special safety distancing. Through this tour, as we go through the public spaces in the building, we'll be ensuring that I, as well as the staff around us, adhere to these rules. And so for these parts of the tour, I too will be wearing a mask. Let's get started. We begin our behind the scenes tour in our vehicle display hall, sometimes nicknamed the Hall of Fame, Hall of Shame, because we highlight the best and worst of each of our crash tests. This provides us with an opportunity to share with you a history of all of the crash tests that we've conducted and their effect on reducing losses on US roadways. All of our high-speed tests are rated on 4 different ratings: good, acceptable, marginal, and poor. The rating comes from 3 different things: vehicle structure, performance of restraints and kinematics, and measures from the dummy injury sensors. We're standing here in front of our side impact display. Our original side impact test began in 2003, and we saw a wide range of performance for these vehicles. Up top, we have a poor performing vehicle. You can see significant structural collapse. We also don't have head or chest protecting airbags, so the dummy inside indicated high risks of injuries. From the same generation, but a different vehicle model, we have a good performing vehicle, and this vehicle had significantly better structural performance, as well as head and chest protecting airbags, which the dummy then indicated low risk of injury inside. While we saw this wide range of performance initially when we introduced our test, many manufacturers made improvements so that now virtually every vehicle gets a good rating in this test. But what we know is that from real-world data, people are still being injured and killed in side crashes, even in good-rated vehicles. So I, along with a team of engineers, have been working for approximately the last 5 years to figure out what can be done to improve on this test. We've discovered that a faster test with a SUV-looking vehicle, similar to what we had for the original test, but updated, will help us to reduce these losses on the roadways even further. This is the kind of test that you will be seeing today. It's an updated version of our side impact test. So let's head over to the dummy lab. We are now outside of our dummy calibration lab, more formally known as anthropomorphic testing devices. The dummy is our main test tool for analyzing crash test data. Dummies come in all shapes and sizes. We have about a fleet of 20 dummies in frontal, side, and rear impact crashes. Dummies come in different sizes, all the way from a 6-month-old, 3-year-old, 6-year-old, 10-year-old, small female, mid-sized male, and large male dummies. This allows us to measure and understand different injury risks for different sized people. Our frontal crash dummies have sensors that are directed more towards the front. Our side crash dummies have sensors and abilities that help us understand side crashes. And the same thing for rear impact. So they're all very specialized. There's not just one crash test dummy. What you have next to me is our SID2S dummy. This is our standard side impact dummy. We've been using her since 2003 in our side impact crash. That's right, her. She's a 5th percentile female, about 5 foot tall and about 100 pounds. And she reflects the most vulnerable population that we noticed inside crashes. So she will be located in the front and rear seats of today's test that you'll observe. I'm often asked, how much does a dummy cost? It's pretty crazy. Dummies can range anywhere from $150,000 to $1 million. And it depends on the complexity of the dummy and the amount of sensors inside. Some dummies are even wireless. Dummies can have anywhere between 40 to 150 different sensors that measure things like accelerations, rotations, forces, displacements, and other things. So now I think we need to go and talk about the crash test process. The time it takes to crash a vehicle from the time it arrives to prep, to crashing, to being done with it is about a week. And the first destination that this car will come is to our photo studio. Our photo studio has soft diffuse light overhead, a cyc wall, and a turntable that allows us to adjust the vehicle to different angles. Our team of professional photographers take these photographs that are used for websites, promotional materials, and research purposes. We can capture the same angle on every vehicle for a vehicle class. We can also capture those angles pre and post crash, so engineers can compare that data. So after they're done with their beauty shots, the vehicle moves to the vehicle prep area. Once the vehicle leaves the photo studio, it heads to our vehicle prep area. Our vehicle prep area consists of about a dozen technical staff that help support the prep and testing of the vehicle. The next step in the process is vehicle measurements. We use a measuring tool like this that's computerized to help us identify parts of the vehicle and locate them in 3D space, both pre and post crash. A tool like this is accurate to the micron. Once measurements are taken, it then heads over to one of the bays behind me. In this area, we install our own test equipment, and we install things like stickers and other components that help us for the crash test process. All of our test equipment in the rear of the vehicle are made by our electronics lab. So we control things like the vehicle system, cameras, lights, and brakes. We also install a different kind of fluid in place of gasoline that's not nearly as flammable, but helps us understand if there were to be a fuel leak. It's colored purple, which is different from any of the other fluids in the car. So if we do see a leak, it's easily identifiable and we can see the risk. Once everything is checked off of our list for vehicle prep, the vehicle can then head to the crash hall. We're now heading down to the runway to check out the moving deformable barrier before the crash. Each runway is 600 feet long with a temperature and humidity controlled shed at the end. So let's go. At the end of the runway is our temperature and humidity controlled shed. For today's side impact test, we have our moving deformable barrier back here in the shed. It's a generic cart that we can use to crash into every one of our side impact tests and creates the same kind of impact. We've redesigned this cart for the new updated side impact test. We've updated the size and shape of the cart overall to reflect a modern SUV or pickup. The greatest project that we've done related to this research has been redesigning the front end, this aluminum honeycomb element of the MDB. The existing MDB that we had was not holding up and was not representative of real-world crashes in this higher speed test configuration. And so we needed to redesign the components, both the size and shape and the stiffness of the different elements in the MDB to better reflect real-world vehicle-to-vehicle crashes of modern vehicles. So this barrier will be coming down the runway at 60 kilometers per hour and striking the side perpendicularly of the test vehicle today. In just a few minutes, the crash test team will be coming by to do their final checks on this, ensuring that cameras, braking systems, and the vehicle itself is ready to roll. Let's head down the runway into the crash hall. So we're heading back into the crash hall for the final pre-checks before we begin the test. You can see the team behind me is checking off the final list items, including making sure that the dummies are fully positioned, final measurements are taken, dummies' heads have been painted, so we have that kind of paint evidence. They'll also be checking other aspects of the vehicle, and when everything is signed off, they'll be ready to roll. So let's head up to the gantry and make sure that we are ready and in position for the final checklist. We're here in the gantry in the crash hall. We're waiting for the final countdown. In the meantime, I'm going to give you a few quick crash facts about our crash hall. We have 3 runways in our crash hall. We're able to run parallel crashes of 2 full-size pickups into each other at 50 miles an hour from these 2 runways. We also have a 3rd runway in which we can run a T-bone style crash up to 30 miles an hour. For single vehicle crashes, we actually have to pull a barrier in the middle of the crash hall. That barrier is made of concrete and weighs 320,000 pounds. Our crash hall also has soft diffuse lighting system. This is to prevent shadows. 750,000 watts of light are given in 3 phases through these light boxes. Lighting is very important when we have high-speed video footage. Our cameras are able to capture a frame every 2 milliseconds during the crash. This data is very important to us because it helps engineers understand the kinds of injuries and risks that are happening. It's amazing what you can see happening in 2 milliseconds or 4 milliseconds during the actual crash. A crash itself only lasts about 100 milliseconds, which is in the blink of an eye. The crash machine operates off of hydraulic power. It takes about 4 minutes to charge the system to be able to run the test. The vehicle will be coming from behind us at 60 kilometers per hour. That's about 37 miles an hour. And it will hit perpendicularly with the test vehicle that we have today. So let's step back and watch the crash.
Charging is complete. The test will commence in 4 seconds. 3, 2, 1. The vehicle is underway.
The crash test team is checking out the scenario right now. They're doing some initial measurements and observations and securing the facility so that we can then go down on the crash hall and take a closer look at the vehicle. One of the most common questions I get is, how did the vehicle do? How did it perform? What rating would it get? Let's go back to the 3 different principles that we have for rating vehicles. Vehicle structure. When we look at this vehicle, it still has a relatively well-maintained safety cage. The structure was pretty well maintained. We won't know the exact numbers until this afternoon when we take the vehicle back into the photo studio and do detailed measurements of both the vehicle with the doors on and vehicles with the doors off to get those exact numbers. We also will be looking at the restraints and kinematics. So the airbags did deploy, and we don't see any evidence that the dummies were able to get out from underneath those airbags. but we'll look at the high-speed video footage to ensure that the airbags came out in time to protect both the front and rear dummy passengers' heads. The third thing is to look at the dummy injury measures from the sensors. The dummies are able to download their data almost immediately after the crash, so within 5 to 10 minutes of a crash, we can get an idea of the injury risks that the dummies are indicating. For this test, we did see a slightly elevated chest and a slightly elevated pelvis for these dummies. While overall we can't tell you what this rating would be, we can give you an idea that this vehicle did a pretty good job of protecting the occupants in this crash. You'll have to wait and find out our final ratings on our website when they're released. From here, where does the vehicle go? The vehicle is going to go back to the photo studio where we take more detailed measurements and a tear down of the vehicle to take pictures and measurements of each step of the way. This is used for engineering analysis as well as for our final ratings. In a typical crash test, by the end of the day, we have all of the components necessary to create a draft rating for the manufacturer. So they walk away from our building at the end of the day with an idea of how their vehicle will rate in this new test. This brings us to the end of our behind-the-scenes tour at the Insurance Institute for Highway Safety's Vehicle Research Center crash test. I hope that you had a good time, and I hope you learned a lot, and please come back again in the future. Thank you. Hi, I'm Becky.
All right. So I hope you enjoyed the behind the scenes tour. And now we're opening this up for questions for either myself or Jessica Jermakian. So to give a quick introduction, I am a research engineer, and I've worked on frontal and side crash test programs at the Insurance Institute. And I also used to coordinate the crash tests, and it was a ton of fun. And now I do research related to developing new crash tests. So Jessica, if you could give a short introduction as well.
Sure. My name is Jessica Jermakian, and I'm the Vice President of Vehicle Research at the Insurance Institute. And I have never coordinated a crash test myself, so I'm missing out on that fun. But I have done research in this area, and one big area of research that is one of the reasons I'm answering questions today is because in addition to an upgraded side impact test program, we also will be in the next year rolling out a new moderate overlap test that will look at the safety of the rear seat, and it will include a rear seated occupant. So I can answer questions about that too.
Awesome. So we had a couple of questions submitted in advance, and I'd like to get to those. And then if people do have additional questions, we'll be going through the chat box. And so please submit your questions there, and we'll be going through, chronologically. We have about a half an hour left, and so we should be able to get to everyone's. The first questions I got were about some of the test preparation and conducting the tests. So how is the alignment of the car to the barrier ensured? We actually have a target on the car that we align with a screw on the MDB. And so we know where the impact location should be. And the screw penetrates into the side of the car during the actual crash. And so after the crash, we can look at that target and determine how close we are. And we typically are within 1 centimeter in any direction of where we're aiming, but we prefer to be even more precise. So within a couple of millimeters, we like to be. And that's why one of the reasons that we upgraded our cart for this new test is that we found that a heavier, faster cart needed a little more stability for us to achieve that. In our front test, we also have a barrier that marker that gets consumed, so it gets broken during the crash, but we can look at it from high-speed footage to make sure that it matches up. And we have some pretty tight tolerances for that as well. How is the stability of onboard footage ensured? We do have onboard cameras, and yes, they do, feel the G's and the forces of the crash. We have some pretty sturdy camera mounts, and rarely do we notice any kind of shaking or instability that would be of concern. The majority of the footage that we're taking for onboard is to gain an idea of the overall what's happening to the dummy millisecond by millisecond. And so if it does shake a little bit, it does not affect our overall analysis. I had a question specifically about the new side impact test, when and if the dummy injury ratings will change for the new test. And we will be releasing new ratings protocols aiming for Q2 of 2021 upon completion of our first set of crash tests. I have a question here about that Jessica might be able to answer. Do we test with child-sized dummies in any of our tests?
So in our ratings programs, we do not test with child-sized dummies. We do have some child-specific rating programs. We rate vehicles on how easy it is to install child restraints in them using the dedicated child restraint attachment hardware called Latch. And we also rate booster seats on how well they position the lap and shoulder belt on a typical 4 to 8 year old size child. We do have child crash test dummies. We do use them for research purposes, but we don't have a dynamic crash test program that that uses those dummies. One thing I will say is in our new moderate overlap test program, where we are using a dummy in the rear seat, that dummy, it will be the small female, and she is about the size of a typical 12-year-old child. So that is, while she's not explicitly designed to be a pediatric dummy, she is in the pediatric size range.
Great. I have a question about number of tests. So how many tests do we conduct per week? And how many tests have we conducted totally? So we do about 2 tests a week on a typical week. And in a general sense, we've tested about 1,000 vehicles in our 6 different crash modes since we've opened the crash test facility. I also have another question. What is the most expensive car we've ever tested? And do we test sports cars? So a couple of years ago, we did get a request to test Maserati Ghiblis, and they were $100,000 a piece. So that was pretty exciting. We do not typically test sports cars like Corvettes or Ferraris or those kind of vehicles. They're very low sales volume, and we don't believe that the clientele buying those are specifically looking for safety when they're purchasing those cars. We try to test vehicles that cover about 98% of what passenger vehicles that are sold, most common vehicles. It's very important that we get information out there for very high sales volume vehicles like Toyota Camrys and Honda Accords, so we can reach the greatest amount of people in terms of giving them the information they need for buying safe cars. Let's see. There was a question about the draft seating procedure for the second row occupants. Will this be used in Side Impact 2.0, and when will this protocol be finalized?
I'll take that one.
Jessica.
Yes, the seating procedure for rear-seated occupants at this point is common between our side impact test program and our frontal crash test program. We did just release an updated version of it, of the draft, back in October. It is posted on our research program's website. So we did make some minor changes in anticipation of the official side impact crash test program getting the crash test being completed. There may be some minor changes to the program just for clarification purposes. We are planning to add some photos that are specific to the frontal crash test mode. They don't affect the side crash mode. So we don't have we expect that it won't take too long to make those changes, but we did put up the most up-to-date version on the research program site in October.
Cool. I have another question that Jessica can probably answer. Could you talk a little about testing of ADAS?
Sure. So we have been testing driver assistance systems and crash avoidance technologies for many years now. We started first with our automatic emergency braking testing when we found consistent and promising results from the field data showing that those systems were effective. Both warning systems and automatic braking systems were very effective at reducing front to rear crashes. And we've been evolving our crash avoidance and ADAS testing program as the years go on. So now we have not only front crash prevention ratings that are focused on vehicle-to-vehicle crashes, we also rate vehicles on their pedestrian AEB. We have issued ratings and reported on rear backing systems. And we don't typically think of this as necessarily, many of us as in the community might not think of lighting headlights as crash avoidance technology, but we also, they're very important in assisting the driver in preventing crashes. So we have been rating those also for many years. We are constantly looking to evolve and looking for the next best technology. We are doing research testing on level 2 systems or driver assistance systems that provide both longitudinal and lateral control, sustained control of the vehicle. And recently this past spring, we put out some guidelines for what we'd like to see in driver monitoring systems related to those technologies.
Cool. All right, why is the new IIHS barrier honeycomb for side softer than the current one? How is this stiffness calculated? So the new barrier is actually a multi-stiffness design, and so some parts are stiffer than the original barrier and other parts are softer than the original barrier. And it makes sense because when you look at the front ends of SUVs and pickups, there are parts that have more air and cushion space, areas right behind the hood or by the radiator, and there's other areas that have the stiffer frame rail elements. And so the new updated design, instead of being uniform in shape and stiffness, reflects those different parts being of different stiffnesses and having different effects when crashing into the side of vehicles. How many test cycles can instrumentation mounted in the vehicle trunk go through? Most of our equipment is extremely durable and does not need to be replaced from test to test. And when we do a thorough check of all of our equipment after every test, including parts of the dummy is inspected and tested in case there's any sensors that are broken. But even with dummies, you can buy the structure of the dummy and keep that dummy for 20 or 30 years. The hybrid 3 dummies that we use in our frontal tests are the same dummies. Most of it, like 98% of it, is the same dummy that we've had since the beginning. Things like sensors may need to be either calibrated or changed out because of breakage, but the actual skeleton of it is very durable. And the same with the testing equipment that we have in the vehicle, and the cameras and lighting systems are all attuned specifically for this high speed, high G event. A question about low-speed bumper testing that maybe Jessica can answer. Low-speed bumper testing has been a tremendous resource for accident reconstructionists. Does IIHS still conduct such testing, or are there plans to resume bumper testing in the future?
We are not currently doing low-speed bumper testing. We have some kind of thinking about our crash avoidance technologies and reducing the likelihood of impact or mitigating the crash is research that is ongoing. but we don't have current plans to resume bumper testing.
Cool. Someone would like a little more background about the Insurance Institute. They understand that it influences safety ratings for potential vehicle buyers, but they're wondering how we are funded. Is that something you could answer quick?
Sure. We are funded solely by auto insurers. We don't take money from any other groups other than the insurers, and the insurers that we get our money from represent over 90% of the US market share. As far as, was there another question there besides funding?
That was it. They just wanted to understand our background.
Well, one thing I did want to add is we do one of the ways that we're most visible is that we do provide ratings, vehicle ratings for consumers, but we also do a broad range of research on topics related to infrastructure and the driving environment, driver behavior, impairment, and those don't necessarily end up in our vehicle ratings, but it is research that we contribute to the field and look through other ways besides our consumer information programs to influence outcomes in those areas of traffic safety.
Do we buy all the cars for our crash tests, or do we get cars from other companies? We purchase all of the cars ourselves, and we purchase them directly from dealers. This now allows us to make sure that we're getting a vehicle that's representative of the vehicles that are purchased by real people and could be driven on the road. And so that helps us ensure that we're being representative with the vehicle that we're choosing for a test. We do have a nomination program where if we're not specifically planning to test a vehicle this year, the manufacturers may raise their hand and say, hey, we'd like you to test this vehicle. We think it will perform well in the test. And in that case, we would still purchase the vehicle ourselves, but they would reimburse us for the cost of the vehicle. We also got a question about how much it costs to run a car crash test. And I believe one of my coworkers did a kind of a general cost analysis a few years ago, and with resources, whether it be the equipment and also the staff time, it costs about $15,000 to conduct a test just with all of the resources that we have. Is further analysis conducted, such as items like the engine cradle, suspension parts, etc., for types of failures? We typically look at the bigger picture overall performance of vehicles, but we understand that manufacturers, as they're designing and tuning vehicles for each of these tests, look at a lot more factors. And even what we measure on the vehicle, we have a very simple accelerometer package that we triaxial accelerometer package that we look at on the vehicle, plus the dummy information for a test. And manufacturers may have hundreds of extra channels of accelerations and rotations and other forces on the vehicle that they're recording during their own in-house testing. That helps them then put this information back into modeling and inform decisions about future vehicle designs or changes. But we do a very simple, we know exactly what we need to measure to rate the vehicles and compare. Every day is a new challenge because we're not testing the same vehicle over and over again. So there's little idiosyncrasies with different vehicles and manufacturers that keep our staff on their toes as they're preparing these vehicles.
Becky, just following on that, can I ask, somebody asked me a question privately that kind of follows on about that, what instrumentation we put in the vehicle. Somebody asked, are they event data recorders imaged, and if so, are they available? And so, as Becky mentioned, we have so much instrumentation on the vehicle itself that we get our own information about how severe the crash is. So we don't image the EDRs as a regular practice in our crash test programs. We have done special studies where we did download EDR data in order to do a specific study, but we don't do it as a matter of regular practice. We have better data than the EDR can give us.
I did that. I did one of those studies and it was very interesting, but yes, often the EDRs don't from one to another even capture the same kind of information. All right. How does the performance of a crash test for a vehicle affect insurance prices paid for that vehicle by owners, or is that pricing arbitrary?
Can you repeat that?
How does the performance of a crash test for a vehicle affect insurance prices paid for that vehicle, or is the pricing arbitrary?
Yeah, so we are not part of the insurance business. We don't work with the insurers to set their rates. That is something that they do 100% independently. One thing I will say is that our sister organization, the Highway Loss Data Institute, gets insurance data, claims data information from about 85% of the US market share that is they use to run studies and report out to the public and also to our member companies. But the insurance companies have access to that aggregate data to be able to look through the claims experience. So I don't know how they're setting their rates related to our crash testing because that is not part of, we're not part of that business. But we do also have this other subset of data that they can use and look at in order to help set their insurance premiums.
How do our tests compare to federal regulations for vehicle crash worthiness? So we try to design tests that supplement what the government is doing. So areas where we identify a problem that is not yet addressed by a test. And so we do not try to have competing or overlapping tests in that sense. And we think that it allows, again, for a better performing vehicle overall if we're able to cover more of the pieces of the pie that are responsible for injuring and killing people on roadways.
And I think an important add-on to that is that when we talk about federal regulation, that's a bare minimum. And what we're testing is not only complementary to their testing, but generally speaking, pushes the envelope a little more to see that differentiation, because from a regulatory standpoint, the vehicles must meet that minimum bar in order to be sold.
Great point. Question specifically about my side impact 2.0 test. Is the anti-roll device removed or included in the new side impact test? The person did not see this in the video. The anti-roll device is installed on mid-size SUVs and larger, and because we're testing small SUVs, it was not included. We're also allowing manufacturers to answer a questionnaire if they feel that the vehicle needs to have this device and it's not in one of the categories that we're currently putting on the outrigger. They can provide evidence to show us that it needs that outrigger, and we will put it on. Our goal is not to have the vehicle roll and our test equipment get smashed. So we're primarily analyzing the side impact test in the side impact 2.0 test. So we're trying to avoid any secondary crashes. And another question, is there a far side test in our protocol? Currently, we are not evaluating a far side occupant in our side impact test. We wanted to focus on a test condition that involved near side occupants in higher speed crashes. That does not mean that we will not, continue to monitor and look into the possibility of this in the future. Why was the CG of the new barrier lowered? Is that the case with new SUVs? Yes, we did build all of the characteristics of our new barrier based on modern SUVs, and we find that SUVs are getting lower, and cars and SUVs are actually becoming more similar over time. So we did try to match both the geometry and the other characteristics, whether it's CG, moment of inertia, and those stiffness characteristics to what we see as newer vehicles. Can you provide more insight into testing the second row occupant injury during rear impact? Are we doing any research on rear impact currently?
So our crash test program that we're rolling out this coming year will focus on front crashes and will incorporate the rear seated occupant. We do, as part of our broader rear seat research that we've been conducting over several years, we do have an aspect that is looking at rear seated occupants in rear impacts, but that is solely in a research phase. It's not something we are rolling out into a consumer information program.
Do we foresee using the Thor dummy in the future?
So we are actively conducting research to understand if the Thor dummy can give us better information and better discriminate the types of injuries we see in the real world data. We know that from when we first implemented our moderate overlap crash test back in the mid-90s, we've seen reductions in all kinds of injuries, but we really haven't seen the benefit to the thorax, to the chest. And we know that when we look at real world data and understand how people are still getting injured in good rated vehicles, that the chest is a concern. That is an injury that people are still getting even in good rated vehicles. So we know that the Thor dummy can potentially give us better information, more information about what's happening in the chest. So we are actively studying that right now. It will not be rolled out if whatever decision we make about the Thor dummy will not be rolled out in this current iteration of updating our moderate overlap test that will happen this coming year. I will say that from our initial looks at the data in our moderate overlap test, we're not seeing a large benefit from the Thor dummy, but we haven't completed our analyses, so you have to stay tuned.
Is our process of testing electric vehicles significantly different from testing of ICE vehicles? We do follow electric vehicle safety protocols to ensure that we keep our staff safe, and we're making sure that the vehicle does not become electrified in any capacity. We follow the federal protocols for doing that. And we also have, emergency staff on hand should some sort of thermal incident be apparent. And we keep the vehicle outside of the building, so if something should happen in the following 2 weeks, which is also part of the protocol, it will happen independently and not burn down our building. So we're trying to keep everyone safe and keep our building intact. But I've also gotten questions about, for the side impact test, what will the structure rating be based on? It will still primarily be based on the B-pillar structural rating. We're sticking with the same kinds of things that we have rated in the past, but the boundaries that we have set for the different ratings categories, good, acceptable, marginal, and poor, may change, and we will hopefully have an update on that in Q2 of 2021. Oh, here's an interesting question for both of us. What safety feature would you like to see on vehicles in the future? Ooh.
You gonna go ahead?
Oh, I don't know. I think this can also tie in, some folks have asked me about whether we're studying pedestrian and bicyclist safety, vulnerable road users. I think that the greatest potential for reducing these kinds of crashes, fatalities, is something like pedestrian and cyclist AEB systems that can detect and warn drivers and intervene. And with fitment of that, I think that we will see a great reduction in this area that has largely been untouched in the US market.
Yeah, I think that's a great answer. I will add from a crashworthiness perspective, thinking about, and we're doing this in our rear seat test protocol and our new test program where we will be looking at seating positions other than the front. I think thinking about how to make safety within the vehicle equivalent for everyone. We know that improvements have been made in the front seating positions that haven't been made in other seating positions. And we also know that there's a lot of variability in how people sit and you know, their comorbidities like their age and weight and things like that, that we could do a better job of reducing the likelihood of injury for a broader set of the population.
And a nice follow-up to that, is there any plan to substitute some crash modes with human body models?
So we are, the short answer is no. We are continuing with our test programs the way they are. We are investigating the concept of virtual testing and whether that involves a human body model or computational models of the dummies is yet to be determined, and how we implement it is yet to be determined. We are just starting down that path. So we are looking at computer simulation in terms of future concept for testing, but we don't have any plans at the moment to change what we're currently doing.
Are children safer in the back seat with the improvements to front seat safety?
Yes, they are. We've been studying this for several years, and with this specific focus of trying to understand what's happening in the back seat. And it's not that the back seat is getting less safe. The back seat is as safe as it's always been. It's just that the front seat is getting safer by comparison. We have seen some data to suggest that, let me say the youngest kids who are properly restrained in appropriate restraints for their age and size are absolutely safer in the back seat still, even in the most recent vehicles with the best technology in the front. We have seen some evidence that as we get to belted occupants, so children who move into the belted age range, may be seeing some benefit from the front seat, but we have not seen that universally across all the data we've been looking at. So we're not changing any recommendations. The recommendation still remains that if you are 12 and younger, you should sit in the back.
Cool.
And we're taking the approach of let's make those back seats as safe as the front from a restraint perspective.
Are there different testing methods with vehicles using different materials like carbon fiber or aluminum heavy construction? We try to accommodate as best as possible, all of our equipment in a manner that won't damage or destroy the different kinds of materials. We know that things like you can't weld to carbon fiber. So if there's equipment that we need to add to the vehicle prior to testing, we ask for manufacturer input. And I think that's one of the fun parts, or the parts that never gets boring for our technical staff, is that since we aren't testing the same vehicle again and again and again, every new vehicle, yes, you have the same checklist to complete, but there's a lot of critical thinking and thinking on the fly about, okay, how do we accommodate what we need to put in the vehicle with this very unique vehicle? Like the carbon fiber vehicle, we've definitely tested a few of those, and some that are aluminum body. And I think an area where this may also be of interest, but is not something that we're actively studying, is a low speed test environment and damageability. Can you repair vehicles that have these different kinds of base materials?
I have another question that was sent to me privately.
Sure.
The question is, any thoughts on unconventional seating positions that autonomous vehicles may result in, and will the testing process change? So this is a big question. We've been hearing about alternate seating configurations for, since we've been hearing about the promise of autonomous vehicles. A big there's been a lot of research focused on trying to understand what the dummies can tell us in these alternate seating configurations, as you saw from the tour that Becky showed at the beginning, that these dummies are highly specialized. They are, you know, we have frontal crash test dummies for front crashes. We have rear crash test dummies for rear crashes. So they're highly specialized, and they don't necessarily, you can't necessarily just put a dummy into a crash in an alternate seating configuration and expect to get biofidelic answers from the dummy. So it is an open question. There's certainly research in this area. There's also research about whether people really want to sit in these alternate seating configurations. So that's an open question as well.
Right. Well, I think we're getting to the end of our hour. We don't want to encroach beyond people's lunch hour, but we thank you for attending this. We're going to put up our slide with our contact info. So if you do have further questions, you can reach out to either of us with those questions. And we'll put out this teaser that we're hoping come spring, we can do a similar behind the scenes tour that focuses on our crash avoidance work. So whether it's AEB testing, headlight testing, some of our other on the track. I know it's not destructive, but it's still a lot of fun. So when the weather improves and we can get some video equipment out there to record all of the cool things that we're doing in that aspect, we hope that you will return and join us for that presentation as well. So in the meantime, I am going to share our contact info. And thank you again for attending this joint event between SAE Detroit, SAE Washington DC, and the Insurance Institute for Highway Safety. If you want to watch more crash test videos and learn more about the broad range of research that we do at the Insurance Institute, you can go to IIHS.org and you can be entertained for hours, I guarantee it. So thank you again.
Yes, thank you all. This was fun.